Okay, here's some example problems on how to do work and power problems. Okay, so remember, power is the work done over time or energy change over time, because energy change is equal to work, and then power is measured in watts, joules per second. Okay, so first example here, if we push a box with a net force of 748 newtons, so again, start with, okay, write down what you have. So we have a force of 748 newtons. Okay. Over a distance, we have change in distance is 8.5 meters. Okay, in 3.5 seconds, so our change in time equals 3.5 seconds. Okay, we look on our formula sheet. The formula for power equals force times change in distance over change in time. We have all those numbers. They're all in the right SI units, so we can put it in to our formula. So force 748 newtons times 8.5 meters divided by 3.5 seconds. So we get 1,816.57 watts. Okay, for significant digits, we have 2. Okay, so it's probably easiest to divide this by 1,000, put in kilowatts, so our power will equal 1.8 kilowatts. Okay, and then on your assignment, it also asks for horsepower, the conversion rate. Once you have this, make sure you convert the watts and you just times it by the conversion factor. Which the conversion factor is for every 1 horsepower, 1.00 horsepower, there is 746 watts. So it just times it. Basically, I'm just dividing this 1,816 by 746. So in this case, I would get, if I wanted horsepower, it would be 2.4 horsepower. Okay, make sure when you're doing it, use the watts, don't use the kilowatts. Question 7, 10 hobbits, each weighing 18 kilograms, is lifted 142 meters in 2 minutes. What is the power required? So again, so we need our mass. Okay, we have our change in distance. Okay, is 142 meters, and then our change in time equals 2 minutes. We'll have to convert that to seconds. And for mass, we have 10 hobbits, and they each weigh 18 kilograms. So we'll have to find our overall mass. And so if we look here, we need force. They're lifted, so they're going against the force of gravity. So we write down gravity, 9.81 meters per second squared. Okay, so this would be 180 kilograms. So we know that Fg equals mass times gravity. Since we know this is equal to this, we can just substitute that into our formula. So power equals, instead of F times change in D over change in T, we can say power equals mg times D over change in time. So we can do that, or you can do it solve for this, put it in there. Either way works. Okay, so power, so our mass, 180.0 kilograms times 9.81 meters per second squared times our change, 142 meters, change in distance. Okay, divided by change in time. I didn't convert this yet, but I can convert it now. 2.0 minutes times 60 seconds in 1 minute. Again, that'll get me into seconds. Now I just do this big calculation and solve for my power. So I get 2,089.53 watts. Again, I have 2 significant digits. So again, like you could put 2.1 times 10 to the power 3. I like to convert to just kilowatts, so you get power equals 2.1 kilowatts. Okay, that's why we have these, is to kind of, then we don't have to write down using scientific notation. Okay, this next question, we have 7,500 watts is used to lift Thor's hammer at a constant velocity, moving at 30 centimeters in 4.5 seconds. So what is the force required? And so first, and then how much? Okay. So we can use our power. We're given our power. So write down what we have. We have 7,500 watts. Okay. We have our change in distance is equal to 30 centimeters. Okay, which is equal to 0.30 meters. Okay, and our change in time is equal to 4.5 seconds. Okay, so now we have our formula: power equals force times change in distance over change in time. We want to rearrange this to solve for force, so we're going to times both sides by change in time. That cancels out on this side, and then divide both sides by change in distance. That cancels out on this side, so we get force is equal to times change in time times power over change in distance. Now we can just put our numbers in. So our change in time, 4.5 seconds times 7,500 watts. Whoops. And our distance is 0.30 meters. So the force needed for this is so 112,500 newtons. We have two significant digits. So I can put in kilonewtons, or I can just, like for this one, I'll just say 1.1 times 10 to the 1, 2, 3, 4, 5 newtons. Okay, and then how much does Thor's hammer weigh? Okay, so we're lifting it, so we're working against gravity. So force of gravity equals mass times acceleration due to gravity. Okay, we know the force. We know gravity is 9.81 meters per second squared, so we're going to just divide both sides by gravity. So our mass is equal to our force. I'm going to use the big number, like the total number, not the rounded number. Okay, divided by 9.81 meters per second squared. And then we can get our mass. So we got, I'm just going to round it. So 1.1 times 10 to the 4 kilograms. All right, and then the last example here, how long will it take to pull a 120 kilogram box of physics textbooks from the ground up a 25-meter vertical cliff with 1,250 newtons of net force and a motor supplying 1,000 watts of power? So we write out what we have. We have our power, 1,000 watts. We have our force, 1,250 newtons. We have our change in distance is 25 meters. Okay, and then our mass is 120 kilograms. We want change in time. Oops, move that down so you can see. Okay, so our formula: power equals force times change in distance over change in time. Okay, we want to know how long. This is our unknown. Okay, so in this case, this is what we're looking for. So we need to rearrange this formula for this. We'll times both sides by delta t. Okay, these cancel out. Now we'll divide both sides by P to get rid of that. It cancels here, so we got delta T, or change in time, is equal to force times distance divided by power. Again, like we'll notice here, the 120 kilograms really doesn't matter. Like it has no effect on our question because we're given the force. If we weren't given the force, you would use this to find the force by times it by 9.81. Okay, but we're given the force, so it's just not needed. Okay, so now we'll put our numbers in. So our change in time is equal to our force, 1,250 newtons, okay, times our change in distance, 25 meters, divided by our power, 1,000 watts. Okay, and for significant digits, we have 2, so our time it would take is 31 seconds. Okay, so those are just some examples. Those are fairly basic ones. Okay, we use the same formula for each. Okay, but if you look like on your formula sheet, okay, really if you write down what you're given, okay, we're going to be using these formulas in here. So like if you're given change in energy or like work, okay, divided by time, you can find power. So that's one way. You can find efficiency. This was the one we were using, but like in this, like there's one question that said add a constant speed, but then it gave us distance over time. Okay, so we just didn't use it. But if it gives us a constant speed, if it said it went 25 meters per second at a constant speed, then we don't need distance or time. We just use our constant speed. Okay, so these are the formulas we're going to be using on your formula sheet. Okay, if you have any questions, feel free to message me on Google or send me an email.